My name's Keith Rucker. We're working on the Oliver table saw now. I've got the tabletop off, and the job that we want to work on now is to get this project clean and rust free. And as you know, this saw sat out in the weather for a while, and we have a lot of surface rust on the top of the cast iron table. Because this is a machine surface, it's flat and should be really flat when we get through. And I can tell by looking at it, it's not out of flat right now, but I want to get a good machine surface. I want to salvage that off of this without having to send it off to get it reground. And to do that, I'm going to use a process called electrolysis to help me clean this up. Normally, when I'm cleaning up rusty parts, I like to use some type of an abrasive to do it. If it is something like just a cast iron part like this right here, piece of steel, whatever, where you're not worried about destroying the finish if you're going to put a paint on it or something like that. So, for example, on this machine here, when I was cleaning it up, I just used a twisted knot wire wheel on an angle grinder, got in there, got all that rust off. The smaller parts, a lot of times I'll put them in my blasting cabinet and I'll sandblast them to get them cleaned up. Bigger parts, I have even sandblasted those. But when you're working with a machine surface, such as the top of this table, you really want to try to avoid using any type of abrasives, just because you can actually destroy that machine surface and you can get it where it is no longer flat. And for me, this is where electrolysis is really a very good option to use. Electrolysis, some of you may or may not be familiar with it. I've had several viewers request doing a little video on this, on my take on electrolysis, and for me this is the ideal situation to do it when you've got a piece and you really want to try to preserve the surface that is on there as well as you can. Obviously, anytime you have rusting, there's going to be a certain amount of damage that's done to that surface through the form of pitting, or just the rust or iron oxide that comes out of the metal, so you're actually losing metal during the rusting process. But we want to try to preserve as much of that original surface as we can, and that to me is where electrolysis comes in. On something where I just want to get it cleaned up and then come back in there with paint and paint it, I'm not so much worried about preserving that finish or that surface. And for that, an abrasive, some type of light abrasive, sandblasting, blasting cabinet, glass beads, a wire wheel, something like that works very well. So this is a great candidate for electrolysis, and I've got it more or less kind of set up here to show you the process of how we're going to do it. We took the tabletop off. I actually took a garden hose, water hose, and some degreaser. I cleaned it up. I tried to knock off, any dirt, any big chunks of rust that would easily knock off by my hand, just to get it fairly clean. I didn't come in here with a wire brush or anything like that and brush it, but I did want to get as clean as I could before I put it in here. And then I set it down into this, in this case, a little plastic swimming pool. You always want to put it in some type of container that is non-conductive, because we are going to be using electricity to come in here and help us with the derusting process. So you want whatever container in here to be able to be non-conductive. Plastic works great. For small parts, a 5-gallon bucket will work great. For larger parts like this, I've got a little kiddie swimming pool. I think it was $12. I bought one at the dollar store, and it makes a great container to put larger parts like this in. So anyway, we got that laid in there. All I'm really worried about is the top of it. I've got that up where I can see it. The bottom part is going to be painted, so yeah, we're going to get some cleaning that goes on with this electrolysis, but we'll probably come in there with a wire wheel and knock that off. So I'm not really too worried about the bottom of this particular piece. So with electrolysis, well, first off, here's the things you need to do electrolysis. Number one, as we mentioned, that non-conductive container to put it in. Number two, you're going to need a battery charger or some other power source. What you need is direct current. And of course, a battery charger is going to give us that DC output. The more amps that you can get out of your power source, the faster the process takes place. But not having a lot of amps does not really keep the process from happening. It's just a little bit slower. And quite honestly, in a lot of cases, we don't want it to go too fast. We want to do it in a controlled way. So I've got a 10 amp battery charger here, 12 volt battery charger, and I've used this many times, and I'll just let it cook really for probably a day or two to let it go through this process. You need some what we call sacrificial electrodes. And those are going to go around the outside of the tank. And you see here I've just got some pieces of steel. Any type of metal will work. This is some plate with some holes in it that I found over on the scrap bin. I'm not even sure what they came off of. I like these because they have a large surface area to them. And the larger the surface area, the better electrical connection you'll have between the parts through the water. So, and I've got 4 of them set up here, and they're all tied together with wire going around the part. Really, you don't have to have multiple ones. One would work, but again, the more surface area that I have and having the electrical current kind of surrounding it, that'll kind of just help speed up the process. You could just take a piece of electrode. One thing to note on this, though, is that during the electrolysis process, you're actually going to erode the metal off of these. So these should be sacrificial. They should be something that you don't want to keep. Because you will, particularly if you use them over and over again. For this short job here, you probably won't even be able to tell anything happened to them, but if you're using them over and over again, eventually it will actually eat the metal away on your electrodes going around here. So other thing you'll need is washing soda. I use Arm & Hammer washing soda. This is sodium carbonate. And basically what it is we're putting a salt solution into the water, which will help the electrical conductivity in the water. Pure water by itself will actually not even conduct electricity. It's the impurities in the water that will conduct the electricity. So you have to have a salt type something in the water. Washing soda works very well, sodium carbonate. Technically you could use other salts. You could use table salt, for example, to do this. It would work. However, you need to be careful and use the right type of salt because whatever you're putting in here, you're going to have different chemical reactions taking place. And for example, if you use table salt, you'll actually get chlorine gas coming off it. Table salt being sodium chloride, and you'll actually get chlorine gas coming off of it. And that's not something you want to be around. So it is careful. You need to be careful and choose the right salt. And washing soda or sodium carbonate is an excellent choice. This you can get at a lot of supermarkets have this in the laundry aisle. This is washing soda. Please note it is not baking soda, which Arm & Hammer is probably more famous for. Baking soda is sodium bicarbonate. This is sodium carbonate. We want to use sodium carbonate or the washing soda. I used to be able to find this in just about any grocery store in town, but here in the last 5 or 6 years, it's getting harder and harder to find this. Most recently, I've had to actually order it online. You can get it from places like Amazon.com, or a lot of online stores will still have this. Arm & Hammer still makes it. And if you can't find washing soda, you can actually use baking soda, but you have to process it first. You have to lay it out, sprinkle it out on a flat pan, put it in the oven, cook it at about 300 degrees, and that will break down the sodium bicarbonate into sodium carbonate. But if you can get the washing soda off the shelf, that's going to be the easiest thing. Then you're going to need some wire, again, just kind of tie everything together, and we will then fill this up with water, put the salt solution in there, and turn the juice on. The way you want to hook this up to your battery charger is also very, very important because remember we said we have the sacrificial electrodes going around the tank, and those are hooked up to the positive lead coming out of here, the positive being the anoid in this case, and that's going to be the part that's going to actually break down and you're going to actually lose metal off of. The part that you want to clean needs to be hooked up to the negative terminal or the cathode, and that's extremely important that you hook the negative up, or you won't actually get rust removal, but you'll actually start breaking down the metal on the part that you're trying to clean, and you'll be removing the rust on your sacrificial electrodes going around there. So very important. Remember, negative goes to the part you're trying to clean, positive goes to the electrodes around the tank. So what we're going to do next is I'm going to take my washing soda here, and I'm going to probably get in a smaller bucket and just get it dissolved. This stuff kind of has set up. It's been sitting on the shelf, so it's kind of hard. I'm going to have to break it up, get into solution. What you want to do is put about 1/3 of a cup to 1/2 of a cup per 5 gallons of water that you're using, and that will give you a good solution to get that electrical conductivity going. So let me go get that going, and then we'll also go ahead and fill the swimming pool here up with water. I'm going to put probably enough to get about an inch above the top of the table, and that'll be enough. And so let's get that going, and we'll come back and we'll talk some more about this process. All right, I'm taking this washing soda and I'm making sure it's dissolved. This is a powder, and if you just pour it into the water, it may just all settle to the bottom and not actually dissolve into solution. So I'm pouring it into a bucket here. And again, this stuff has been sitting around for a while, and as you can see, it's gotten hard on the inside of the box. But I'm just taking a little piece of metal and scraping it, and it's tearing back apart very easily. It's not a big deal, but it is a little bit extra work. If this had been a fresh box, I wouldn't have to go this extra step. And then I'll just pour that powder in there and stir it around and get it into solution. And we'll do this because of the volume of water I'm going to use. I'm just going to put this whole box in here. So this is about 3 pounds of product here, and that should give me plenty of salt in here to conduct the electricity for this. All right, we got this cooking here in the stew. Let's see what we come up with. So basically what we got here is a nice little chemistry experiment. In fact, the first time I ever saw electrolysis was in 7th grade in a science class. We actually did this as an experiment in class, not to remove rust, but showing how the process works, where you have the cathode and the anode, run electricity through that within a salt solution, and you break down the water into its components. Of course, water is H2O, 2 parts hydrogen to 1 part oxygen. And when you run electrolysis on here, actually what happens is you break that down into oxygen and hydrogen. So, and I got my cheat sheet here to remember this. On your anode, on the positive side, you'll get pure oxygen coming off of that. So our positives again are the sacrificial anodes in here. So coming off of these is going to be oxygen. Off of the part itself, you'll actually get hydrogen going. I remember we did this in the experiment class where we had the cathode and anode in the water. We put a test tube over the top of those to capture the gas coming off of it. It bubbled out, and at the end we actually took the test tube with hydrogen, pulled it off, took a little Bunsen burner, and you could see the hydrogen burn off of it. Really neat experiment to a 7th grader. I still remember it to this day. And that's exactly what we're doing it. In fact, the term electrolysis, when you break that down, the electro and the electro means electric current, obviously, and the lys means in Latin to break down, to break a bond, or to tear apart. So we're tearing apart that water molecule into its hydrogen and oxygen components. Now what's neat is when you have iron or oxide, which is rust, ferric oxide, Fe2O3 is rust. That's the red rust that you see. That's a very active form of that. It's an oxide. It's very active. It grows. It will continue to get worse and worse over time. But what's interesting is when you go through this electrolysis process, you actually chemically reduce the rust into a more stable form. We turn it from ferric oxide, Fe2O3, into magnetite, which if anybody's ever panned for gold, that's the little black things that you find in nature quite often. Magnetite is Fe3O4, so it's very similar to rust, but it's actually been reduced down. But the magnetite is very stable. It's not going to continue to rust. So we basically are stopping the rust process. And the interesting thing too is, the way I understand this, is when the electrolysis process is going on, you actually will take some of the iron out of the rust, out of the ferric oxide, and it'll actually go back to the metal. It's not as stable, I guess, as the iron that was in there originally, but you can actually get some of it to go back to the iron form, the stuff that's real tightly bound there. So it stabilizes it, it removes the rust. When we come in here, that red rust that was on here before will basically be black magnetite, and you can just take your hand and it'll just rub right off and clean up very nicely, and that's the process that we're going to use here. So electrolysis means to electrically break down, and that's what we're going to do. We're going to electrically break down not only the water in this case, but in essence the rust. We're not breaking it down, what we're changing its chemical format from ferric oxide to magnetite. So we're going to just let this sit here and cook for probably a couple of days, and just let it work through this process and convert all of this ferric oxide into magnetite, and we'll come back and we'll check it out. I can already see it working here. You know, I've only had this plugged in for maybe 5 to 10 minutes, and you can just see in here the bubbling coming off of this, particularly right here between the cathode and anode. Right along that surface there, you see a lot of bubbling. That's the hydrogen bubbling off. And what will happen is obviously right here is the strongest electrical contact between these two parts right now all the way around. But as this all converts over to magnetite, it'll just work its way across the entire surface and cover the whole thing up like we want. So like I said, we're just going to go off and let this cook for a couple of days, and we'll check on it here and give you an update on this soon. So here's an update on the progress of the electrolysis. We turned this on yesterday afternoon. It's the following day now. It's been cooking here in the stew for about 20 hours now, basically just overnight and into the next day. And you can tell that things are starting to work here. So number one, you see over here near the electrodes where we have this froth coming up. That's real typical. You'll get this as it's cooking. And what you'll need to do is periodically come in here and just clean these electrodes so that you've got good contact. Also, if you look on the table itself, you start to see some black magnetite forming there where the rust was all around the table. So this is again a sign that the process is working. At this point in time, what I'm going to do is I'm just going to come in here and take an abrasive and just kind of wipe the top of the surface, clean it off. Even the rust that's on there is changed colors and form. It looks like it's just kind of a powder on there. And I'm just going to take a little 3M pad and knock all that off. I'm also going to clean up my electrodes around the outside there to make sure I got good conductivity, and we're going to let it continue cooking. But you can tell it's still going here, still bubbling up. Let's see if we can focus there. You can see it, the bubbles coming up off of it right there. Alright, I have disconnected the power from this so we don't have any juice going through it, and I've just got a little gray 3M abrasive pad here, and we're just going to come in here and knock the rust off of this, and I'm seeing a nice black surface up underneath that surface rust on top, which again tells me this is working. The magnetite, the rust is being transferred from that red state to this black state, which is the magnetite. So hopefully by knocking some of this off, we'll get a little more surface area going with the water, and we'll let this continue cooking for a little while. Get this cleaned up. Also going to clean off my electrodes while I'm at it. So here's an update on the electrolysis project. I just pulled the tabletop out of the tank. It's been in there cooking for about 3 days now, and just real quickly I took a one of these little nylon Scotch-Brite type like pads and sit there for about 5 minutes, just you know, kind of rubbing on here and working it in. And when I rinse it off, you can see I've got shiny metal on here. You can actually see the rule that they scribed in here for the fence, for measuring the fence. So you know, it's looking good. This is, you know, it's going to take some elbow grease now to get in here and really clean this top up, but this would be much easier doing it this way than had I just tried to come in here and take it off any other way. This electrolysis works really well for this. In fact, as it's drying up here, even these areas I haven't rubbed, it's actually looking pretty good. So it's not going to take a lot, I think, and we'll be able to get this top back in tip-top shape again. So let me get to putting some more elbow grease in this, and I'll give you all another update after a while. So we've had this sitting in the electrolysis tank more or less for about 5 days now. I have periodically during that time taken it and just using a pad here, sometimes in the tank. One time we pulled it out of the tank, but we've cleaned all the rust off of it and got it back down to more rust up underneath it and let it continue cooking in that tank, like I said, for about 5 days. I'm to the point now where I'm pretty happy with it. We've been giving it a rub down this morning, and I tell you what, let me just rinse it off here, and maybe you can get an idea of what it looks like. If the light will cooperate with us this morning, but we've got a pretty nice finish on this now. It's still got some dark spots in here, but as rusted and pitted as this was, or it's really not pitted too bad, but as rusty as it was, I'm pretty happy with this. You know, we could sit here and continue polishing it and get a really nice surface on it, but for today anyway, I think we're going to call it quits. We may try to polish this out some more later at a different time. But as you can see, the results from electrolysis were excellent. We took a piece that was, you know, really rusted up here and brought it back to life. Again, cast iron is not going to pit as bad as steel will, and you can use this process on either cast iron or steel. So electrolysis is a great option. Again, I really like using it on machine surfaces where we're trying to preserve that surface. Electrolysis is a great preservation tool. In fact, it is a tool that is used by people who are preserving artifacts. As example, the USS Hunley, the Civil War submarine that was recovered from Charleston, I don't know, it's probably been 10 years ago now. When they pulled it out of the ocean, they immediately carried it and put it into a tank and started running electrolysis on it, and ran electrolysis on it for years and years and years. I can't remember how many years, but for 7, 8 years, something like that, they ran electrolysis on there, because that helped to convert the iron oxide, the rust that was in there, into a more stable form in order to preserve that artifact. Another example that I saw electrolysis being used in preservation, again in a ship situation. I was in Corpus Christi, Texas a couple of years ago, and had the opportunity to visit the USS Lexington, which is a aircraft carrier, I think a late World War II era aircraft carrier, if I remember right, that is on display as a museum ship now. And as we were boarding the ship, there were signs outside the ship talking about the history and some of the preservation things they'd done. And one of the things they do is they actually have that ship basically set up and doing electrolysis all the time, sitting there in the ocean. So they put a negative charge on the hull of the ship. Around the ship in the bed of the ocean, they put the cathodes out there, the positives, and they have electrical current running through there. Of course, the ocean is a great electrolyte solution, so you have that salt in that ocean to conduct the electricity through there, and it was just a very low amperage, but still, by running it continuously over a long period of time, they're able to help preserve the hull of the ship so that it will last longer. So it is a great tool. Before I finish too, I want to just mention a little bit more about safety. And you know, we talked earlier that you get the two gases off the anode and cathode. You get oxygen and hydrogen. Remember that hydrogen is explosive. It's an explosive gas. So be very careful. You know, in order to get enough hydrogen to really be in a concentrated form that could cause an explosion, you would probably have to capture it. But try to be careful and not use electrolysis too much in a confined area. So you wouldn't want to really use it inside of a basement shop or something like that, because you could get the hydrogen level built up in there to a point where, you know, possibly you could get an explosion. I've never heard of that happening. As long as you've got some air movement, you're not going to build up enough hydrogen gas really to cause any problems unless you're running a really, really high amperage. But that is something to be cautious about. It's best to be on the safe side. I like to do it outdoors. The gas is just going to off-gas. It's not that big of a deal. We have hydrogen in the atmosphere naturally at some concentration that's not an explosive concentration, so we're not hurting anything. And you know, speaking of that, just another story about how electrolysis is used. Again, I don't know why I keep going back to naval examples, but on submarines that are underwater for, you know, months and months at a time, they actually use electrolysis on board the ship to generate oxygen. So they take seawater in, they capture the oxygen coming off, they vent the hydrogen outside the ship, and that's how they get oxygen levels up in a ship for a long period of time. At least that's what I've been told. Some of you guys may correct me on that, but that's what I've always been told, is electrolysis is how they generate that oxygen that's being used up on a submarine. So there you go. Again, it's a great tool. You know, for most applications, again, I'm going to use something like a wire wheel to knock that off and clean it up, or I'm going to put it in my blasting cabinet and blast it off, particularly if it's just going to be a painted surface. But on machine surfaces in particular, or in a situation where you're trying to do some conservation, where you have excessive pitting and you're wanting to stop that rusting, electrolysis is a great option. So there you go. Again, thank you for watching, and thank you for subscribing to my channel.